it'd probably be helpful to have your unit circle handy for this assignment. It'll make it a little easier. Draw one triangle for each given angle. Label the sides with the hypotenuse being 1. So first thing I'm going to do number 3 with you. So I'm going to turn this into degrees. That would be easiest for me. So if we're converting pi over 3 to degrees, remember you would multiply by, we're getting rid of the pi's, right? So we'll put them in the denominator, and it's always 180 degrees. Now you could write pi radians for both of them, but I mean, you're fine. Oops. So you can cancel out the pi for pi, and then how many 3's go into 180? 3 goes into 18 6 times, so it'll go into 180 60 times. So we just have 60 degrees. Now let's think about a 60-degree angle. That would be in quadrant 1. Right? So let's start here. It wouldn't make it to 90. So there would be our 60-degree angle. Draw a triangle. Okay. Label the sides with the hypotenuse being 1. Okay. Our hypotenuse is 1. So remember the short side would be 1/2 of that. So 1/2. And then the other side would be 1/2 times the square root of 3, which is root 3 over 2. Again, that's a number you're going to see so many times. That's it. So number 4, we're going to do together. As long as I don't lose it. There we go. Write in the angle measures for each quadrantal angle. Label the coordinates with a radius of 1. All right. So the top would be 90 degrees. The left would be 180 degrees. Down here would be 270 degrees. And here would be 0 degrees and 360. And remember, there's all infinite coterminal angles here. Let's also put it in radians. So remember, one full rotation would be 2 pi for 360 degrees. Half of a rotation would be half of 2 pi, which is pi. 90 is half of 180, so 1/2 pi you write as pi over 2. So each 90 degrees is half a pi. So here's half pi, whole pi. This should be 1.5 pi's, but that's written as 3 pi over 2. And then 2 pi, which would be 4 pi over 2. Let's also go ahead and put the coordinates. We'll put our circle on there. So to the right would be 1, 0. Straight up would be 0, 1. Straight to the left would be -1, 0. And down here for 270 would be 0, -1. Awesome. That wasn't too bad. Getting to the next slide, that's the tough part. All right, list the reference angle for each of the following. I want to do certain ones with you here. All right, we'll start with 5. 210 degrees. Now think of where that would be. So you don't need to draw this, but 210 degrees would go beyond 180, but not quite to 270. So it would end up in quadrant 3. And when you're looking for the reference angle in quadrant 3, you do your angle minus 180 degrees. So we can do 210 degrees minus 180 degrees, which leaves us with 30 degrees. That's our reference angle. On most of these, I think it's easier just to convert them all to degrees. But if they're giving it to us in radians, they're going to want the reference angle in radians as well. So 7 pi over 3. Now if we're doing thirds, one full rotation would be 6 pi over 3. So if we kind of thought of that, this will be 6 pi over 3. This will be 3 pi over 3. Up here would be 1.5 pi over 3. Down here would be 4.5 pi over 3. So we're looking for 7 pi over 3. That's going to be beyond